Hi friends, welcome to the Unit 1, Day 1 notes. Today we're going to get an example 3 using the problem-solving guide. The problem-solving guide is a multi-step process. It relies on having 6 characteristics. These are traits that you as an individual have to be able to help problem solve. A positive attitude, mastery of basic facts, strong mental arithmetic skills, or arithmetic skills, good mental visual skills, good estimation skills, and a willingness to persevere, not give up. So what we're going to do with those skills is develop the guide of gathering and organizing information, make the problem visual, develop an equation model, sorry about that, and then use the model to give an information to problem solve. So what we have for this particular problem, this word problem, Ms. Thompson and Mr. Brumman are traveling to the Columbia for a college algebra teaching study, or CATS. That's just setting up the problem. It really has nothing to do with solving it. Just to give you some background information. The trip takes 2 hours for Miss Thompson and 2.5 hours for Mr. Brumman, since he had to pick up textbooks 40 miles further away. Mr. Brumman travels 5 miles per hour faster than Miss Thompson. Find their average rates. One of the things that you want to do as you approach the problem, and a lot of students do this, is they'll underline the numbers. Also underline the units that go with them. For example, if I'm going to underline 2 here, I would also underline hours. And then I look for anything else that has hours that goes along with it. So I note that I have hours, and hours is a unit of time, which is helpful when I'm developing some sort of formula later on. So I've got that piece. The next piece I want to look at is, looks like I'm talking about, oh, here it said 40 miles, and then miles is a unit of distance. And then I also have here 5 miles per hour faster. So 5 miles per hour faster. So miles per hour. That is a rate. So knowing these, that I'm looking at time, distance, and rate, I'm looking to see, is there a formula or something that I can follow that helps me, kind of visualize this? And that is distance equals rate times time. So now with that information, I can then go back and look at this problem. It looks like I'm talking about, in comparison, it says find their average rates. They, in this case, is Mr. Brumman and Mrs. Thompson. So I'm going to use a capital T for Thompson and a capital B for Brumman. Now to organize this information, I'm going to use a table. And then I'm given time, distance, and rates. So what I'm going to do is setting this up kind of in this formula here. Distance is it looks like what I'm needing. Maybe, they find their average rates. So just as long as you listed them out here, you're fine. I usually give a little bit of space to work. And then time. There we go. All right, so what do I know? Well, I know time-wise, for the time portion, it took 2 hours for Ms. Thompson and then 2.5 for Mr. Brumman. I know the rates. I know that for the rate, Mr. Brumman traveled 5 miles per hour faster than Ms. Thompson, so we'll call Ms. Thompson's rate R, because that's unknown. Remember, we're finding their average rates. And then Brumman traveled faster. Now the distance is also kind of unknown. We got part of it. Mr. Brumman had to pick up textbooks 40 miles further away, so we know that 40 miles is going to play into it here. The distance, we know that's equal to the rate times time, so I can take the distance, so 2 times r, so that would be the value for Ms. Thompson, and Mr. Brumman would be 2.5 times r plus 5. And then to make these so that they're equal, then it looks like Mr. Brumman is traveling 40 miles farther away, so we're going to have to kind of keep that 40 miles, kind of keep that into our mind. So to get them, so let's think about if we want them to be equal to one another. So we want the distances to be the same. What we can do is we can then say, oh, well, if he traveled 40 miles farther away, then to make them equal, then we can just add in those 40 miles to what Miss Thompson's time is, and that will make them equivalent. So we can set these equal to each other and then solve. The distances now would be the same if we account in for that extra 40 that Mr. Brumman traveled. So if we do that, we're going to have 2r, sorry, my pen, 2r plus 40 is equal to 2.5 times r plus 5. So if I multiply through 2r plus 40, that is fine there. This I need to distribute. So I have 2.5r plus 12.5. Yeah, 12.5. 2r plus 40. All right, so now I need to get the variable by itself. So I'm going to subtract 2r on both sides. So let's see. I'm left with 40 on the left-hand side is equal to 0.5r plus 12.5 minus 12.5 on both sides. So 40 minus 12.5 gives me 27.5 is equal to 0.5r. Divide by 0.5, or just multiply both sides by 2. And we end up with our rate being 55. To answer in terms of what's going on in this question, we would say that this is 55 miles per hour. So their average rates were 55 miles per hour. Their average rates were 55 miles per hour. This next one. An order comes into a pharmacist for a 15% solution. How many milliliters, ml, of the 20% solution must be mixed with 10 milliliters of the 6% solution to obtain the desired 15% solution? So our goal here is to get a 15% solution. We've got, let's see, we've got a 15%, we have a 20%, and we have, okay, so our goal is to get a 15% solution, and we have 6%, and 20%. So if I think about in terms of like the different types or values that I have, looks like I have a percentage of a solution, and sometimes we'll call that the concentration. And then it looks like we have milliliters, and the milliliters is volume. So let's see how this relates. Again, setting up my table, my values that I'm working with a 6%, a 20%, and I'm hoping to obtain a 15%. So I have, let's start with our knowns. We're trying to get a 15%, so I have a 6%. I have a 20%. I'm trying to obtain a 15%. So that's what I'm trying to work with. One of the values that I know also is I know that we're trying to mix the concentration amount. We're trying to mix the concentration amount with, let's see, we're trying to mix concentration amount here. So we'll call that X. X is our value of concentration. So we're trying to mix that. And we know that we have 10 milliliters of this amount. And then it looks like to get the 15%, I'm going to be adding in this 10 plus X. So now if I think about the 6%, 20%, 15%, those are actually, the percentages, those are actually decimals. And if I take 6% times 10, I get 0.6. And if I take, 0.06, excuse me. 0.06. Thinking 60%. Be careful, common mistake. 20% times x is 0.2x. And so then these added together is going to get my value that I need for 15% times 10 plus x, or 0.15 times parentheses 10 plus x. So what I have here, if I take the 0.2x and the 0.06, and if I add them together, 0.06 plus 0.2x, I can set that equal to what I have here on this side, the 0.15 and the 10 plus x. So I'm going to go ahead and distribute the 0.15 times 10, so that's going to give me 1.5 plus 0.15x, bring down everything on the left-hand side. If I subtract 0.15x on both sides, so I have 0.06 plus 0.05x equals 1.5. minus 0.06 on both sides. So I have 0.05x equals 1.44. Where did I make my error? My error back here. It was 0.6. I had it correct on my marking. I apologize. Some of you are probably screaming through this. All right. So let's go back and fix this. I apologize. All right. Whew. So 0.6, 0.6, 0.6. All right, so here I'm subtracting 0.6 from both sides. If I do that, I don't get one. There we go. Whew. That was not looking good. So 1.5 minus 0.6 gives me 0.9. There we go. There we go. Divided by 0.05 on both sides. That gave me the value that I wanted. So x is 18. In this case, that 18, that's what we're trying to find. That's the milliliters of the 20% solution. So we need 18 milliliters of the 20% solution. Sorry about that. Feel like I make that mistake every year. I need to make a note in the notes. I apologize. Well, thank you for persevering with me on that problem, and hope to see you in the next video. Bye.